I'll try to make it exciting. I've been doing this job for a few months now, since May, and it's the most exciting job I've had. I hope I'll be able to share some of that excitement with you. So I was a developer. I still think of myself as a developer, but I notice I don't really do much development. I checked in code into our production product a week ago. I was all excited. It was the first time I'd done that in years. And I do Python scripting and other things, but not really production code. I've been doing AppSec, I think it's about 18 years exclusively, which I guess makes me one of like the old ones in the industry. I've been doing the OWASP top 10. I even worked, I think, on the 2004 one. You know, and been doing that for years, right? I was a co-lead on the 2017, and we're starting to work on the 2021 now. Yeah, and I'm the Poloniex security architect, right? Poloniex is a cryptocurrency exchange purchased by Circle. I'm responsible for its security. This is my hero, right? I don't know if you guys are aware, there's an action figure called Geek Man. I get no commission if you buy one. It's very cool, right? My Twitter icon, he's my hero. I have one, but I've never actually touched him because it would seem to ruin it opening the box. Okay, so I'm gonna have a few slides sort of explaining what cryptocurrencies are, what an exchange is, why someone would care, and then we'll jump into the meat of the talk. So most people are familiar with Bitcoin, right? Everyone knows Bitcoin. Can you raise your hand if you don't know Bitcoin? Fooled you. Everyone knows Bitcoin. Okay, so there's actually a few thousand of these, right? I looked it up, right? There was 1,700 almost that I was able to find on a site and that site has listing standards. They don't list every coin, so 1,700 of at least some repute. Most of them don't have much repute, but there's a lot of them. So, you know, the basics about them are, you know, they're blockchain based. All of them are blockchain based. I don't think there are any examples. They're decentralized. That was a big thing with Bitcoin. Some of the cryptocurrencies have tinkered with the decentralization, making it less decentralized in exchange for security or in exchange for performance. But they're all relatively decentralized. One of the key things at least for an exchange, is that they're tradable. They're what economists call fungible. If you're not like an economist or into crypto, you've probably not heard that term. A fungible asset is two assets that are the same, right? If you have $2 bills, I say I'm gonna give you one, you don't care which dollar bill I give you. You know, this would be different than, let's say I had two cars, you know, not necessarily new cars, and I say I'm gonna give you one, you would probably have a very strong opinion which one. So the fact that cryptocurrency is fungible, the fact that one is the same as the next, it makes it easy to trade. You don't care which Bitcoin you get, you just want Bitcoin. So the exchange itself, we don't own any cryptocurrency. What we do is we provide a place for people who are looking to sell cryptocurrency and people who are looking to buy the other. So if you have some Bitcoin and you want to turn it into Ethereum, that's the Ethereum sign on the left there. You want to turn it into Ethereum, you're going to need to go find someone who has Ethereum and is looking to buy Bitcoin. And so you go to an exchange, right? And we provide the connection between people who are selling and people who are buying. We go ahead, we make the transaction, we guarantee it happens. There's no you'll give them your Bitcoin and you won't get your Ethereum, right? It's an atomic swap that we implement. And you know, the purchase happens. You know, if you want, you can think about this like if I had dollars and I wanted to trade it for euros. You know, I can go to an exchange, I could either go to a bank and then let the bank, you know, charge me whatever rate they want, or I could go to a site like ours, which will have people selling euros at the best rate available. I could pick, you know, and buy it at the best rate. So it's sort of along that, you know, very much like a currency sort of thing. So I don't really talk much about the site, right, which I frequently say Poloniex, that's my cryptocurrency exchange. There are things in here that are not part of my cryptocurrency exchange. I spend a lot of time looking at our competitors. looking for ideas. So in other parts of the talk, I'll mention things. That doesn't mean we implement them or that we're planning on implementing them. It just seems that it's state-of-the-art technology. So this is the Exchange page on Poloniex. It's a lot of page. So if we start right up there at the markets, what this is this is the list of two currencies, right? In the previous slide, I had Bitcoin and Ethereum. So here across the top are the 5 major currencies we support. So here, if you have USDC and you want to trade it for one of these, you would click on it, and that would then turn the rest of the screen into a USD. Well, currently where it is a USDC Bitcoin swap. So either you have USDC and you want to sell it for Bitcoin, or you have Bitcoin and you want to sell it for USDC. Down here at the bottom, we have what we call the order book. This is the list, and it's a scrollable list, and I cut it off for space, but it's a scrollable list of all the orders that are currently in the market, right? So it's 100% visible. If someone's looking to buy a currency, if someone's looking to sell, you get to see what there is, what the price is. You have the full access to it. So here we have someone who's looking. We have people who are looking to sell Bitcoin to buy USDC. This is the amount of Bitcoin they're looking to sell, the amount of USDC. This is the price in Bitcoin. No, this is the price in USDC they're looking to sell it for. You'll notice the prices are sorted. So if I were to come up here and look to buy, 3,000, let's say USDC, I would buy this entire order, right, which would be 1,106, and then, 1,894 of this order. So I'd get, 1,100 at this price and 1,894 at this price. I think it's fairly common for other sorts of financial exchanges. The rest of it is, right, up here we have like history, charts. They're interactive, they're kind of cool to play with, but not relevant for the talk. We have where you could actually make your orders, right? You could either you have USDC and you're looking to buy Bitcoin, or you with it, or you have USDC and you're looking, or you have BTC and you're looking to sell it to buy USDC. The last thing over here is just notices where we tell people about current things on our sites. We also do some marketing over there. Usually, though, we support 60-something cryptocurrencies, and there's usually a problem with several of them at any given moment. So we pop it up in the notices. Our customers are pretty understanding that that's going to be the case. Okay, so here's the architecture. And this isn't necessarily, right, you can't like go match this to what we run, but this is sort of the high-level architecture. I think as you start at the left, it looks very much like a normal web application. You have the clients here that are sitting on the browser. We use Cloudflare for DDoS protection. It also provides a web app firewall, rate limiting to help protect us against things like password stuffing. We then, in yellow, we have the front end, right, which is, we have a UI, which serves up static pages. We have an API. Almost everything is in the API, right? There's like, nothing's really sort of embedded in our HTML pages except JavaScript code to go call the API. In purple in the center, we have our business logic, right? That's the trade engine. That's the thing that matches up people who are buying and selling and executes the thing. It's the left side that's funky, the blue, right? Normally in like a 3-tier architecture, there'd be a database there, or a database with an API, a REST API, something there. Our database of record for where the money is sits outside of our system in these blockchains. That is very freaky. We don't own those blockchains. They are distributed, part of a distributed computer around the world, being run by people who are, right, who we use the term they're selfish, right? They do what's best for them. And we just hope that the rules are appropriate for them. And when we need to talk to those blockchain, let's say we want to figure out how much USDC, how much Bitcoin we have in our account, we need to talk to the block team. We need to run a wallet. That wallet software comes from the coin development team. It is not our software. Though you may notice it is running inside our data center. and it will handle, on its own currency. Our small currencies have hundreds or thousands or millions of dollars accessible to the wallet. The bigger ones, Bitcoin, I don't know how much we have. We keep most of our Bitcoin cash not online. We keep it in a cold storage. So it's very freaky that we have to rely on the data of record being off, and then we have to have a wallet there that is trying to read it, because the blockchain is not a simple data format to parse. What the wallets do is they fill in our wallet database, and then we can we could ask SQL type questions, how much money is in this account and such. Okay, so here's sort of the last overview slide. So why are exchanges such a juicy target? And they are. We are under attack 24/7. Seeing, password stuffing attacks in the tens of thousands an hour is, we go months and months, right? I can't imagine how much they're spending on their botnets to do this. We see all these things. We see lots of attacks, and I'll talk more about them. So first thing is, cryptocurrencies provide near instantaneous transactions. Bitcoin's one of the slowest. I think it has a 6-minute block time. So it takes 6 minutes for something to happen. If somebody has money in us and they say withdraw the block time, it could take up to 6 minutes till they actually get their money. But once they get it, it is theirs. There is no way for us to get that money back. I mean, it is cryptographically impossible unless something's wrong with our cryptography. So we've lost the money. We can't contact an insurance company. We can't contact a credit card and try to do a clawback. We can't, if you're doing an interbank transfer, you could contact the other bank and say, send me the money back. There is no way we could do that here. Which means if you're a crook and once you get the attack done, it's yours, you're done. Now you of course have to worry, they might come after, you sent it to another account, they might come after you there, but it's really nice that the attack happened. There's no way the bank to pull it back. The blockchains provide, a fair amount of anonymity. Things that actually happen on the blockchain are anonymous. You don't have to give your driver's license to get an account on a blockchain. All you need is a private key. When you deal with exchanges frequently, most exchanges that support the US require you to have ID, social security number, passport to interact with them. But that's only while you're dealing with those exchanges. Once you get it back out to the blockchain, it becomes anonymous again. Regulation and enforcement, it's evolving. It used to be nobody in government knew what to do with this. Now we're starting to get questions from government. They want us to send them their Bitcoin that, generally what happens is they track terrorist money or a criminal money into our account, and they want us to, they take possession of that Bitcoin. They have to go through lawyers. I don't worry about, to make sure it's all legal, but, that's what happens. All right, big thing is, it's a lot of money. All right, this was the December 2nd. It was something like 10 times this, December 2nd of 2017. So it was an even bigger target, but what is this, $129 billion, $130 billion. So that's still a pretty juicy target. So I broke the attacks up, sort of the way I think of them, into 4 categories. We'll talk about the first one, attacks on the application layer. I only have one slide on this because I don't find it, right, it's not particularly crypto exchange specific. These are what happens, right? You have a mobile web app, you have a website, you have a native app running on a mobile phone, you have DDoS, CSRF, all these standard attacks. Now, the attackers are very motivated. As I mentioned, right? I mean, I told you we've seen 60, 70,000 credential stuffing attacks an hour from botnets. And we see that, like I said, commonly. But the attackers are very motivated. But these are, there's a lot of discussing what the defenses are. We use captures, which provide a terrible UX, but help with a lot of the bots. We have Cloudflare for DDoS protection. We do all our, secure cookie settings. We sort of get everything done. You know, and you have to, right? Because this is the first layer, right? When someone comes to look at your site, this is what they see first. So we need them to run their scanners and absolutely fail on this 100%. So jumping on, so we have these wallets. These wallets are third-party code that we're running, as I mentioned. They sit inside our firewall. Every transaction we do with a blockchain goes through these wallets, right? The wallets are the ones that know how to talk to protocol, know how to find the other nodes that are in the wallet, the other nodes that are in the blockchain, et cetera. So this would be like, if Bank of America were to say, if you were to say to them, look, you guys could go ahead, write your whole computer system, do everything, but every time you need to move dollars, use this code from somebody you don't know, okay? And they'll move the dollars for you. You can trust us. Or you could trust them. That is kind of freaky. And not only that, but we have 60-something currencies, so we have to do that 60-something times. And there have been cases where exchanges have installed malicious wallets that extract the private keys and steal all the exchange's money. So this is not just a theoretical concern. There have been cases of this happening. So we have to start out, we have to trust the development team to some extent. And that, I'm not going to talk about how we do that, but that involves communicating with them, reading about them in press, looking at the people's histories, right? Most of these people, at least now, most of the people have worked on multiple projects. So we sort of look at their pedigree. If we don't support them, if we don't trust them, we can't run them. That said, we only want to trust them a little. Not only, even if we trust the individuals 100%, what happens if one of their GitHub accounts gets hacked and somebody checks in bad code into the GitHub repository that makes it into a production build and comes out? I mean, it doesn't have to be maliciousness on the team. So what we do is we run their code, first of all. We never run it in our address space or in something that's not protected. Right? We run it either in a Docker container or a VM, depending on what the security requirements are and how Docker friendly. Most of the wallets now come with a spec to run inside of Docker, so that's pretty easy to get done. We tried not to give the wallets the private keys. Some wallets allow you to manage your private keys separately. It is a lot more work to interact with them. You need to keep track of where your funds are and tell them move this money from here to there, and then you need to sign it. And basically, you're only using the node to talk to the network. The wallet is only talking to the network. It doesn't have access to your private keys. Lots of wallets won't support that, so we try to minimize the amount of access we give them. A big thing we do is we keep most of our money not on the network. Right, we have this concept of hot wallet, which was what was shown in the architecture slide a few slides ago. Most of our funds are stored offline in cold storage. That is the most secretive thing in the company. I have suspicions of who maybe has access to the cold storage, but I don't know. I don't know where the cold storage computers are. They're not in our buildings. They're not on our sites. And so there, what you do is, and they're definitely not on the network, right? So if we were to, so if an attacker comes on, they can drain, the few $1 million that we have sitting around in our hot wallets, right? And then the process would be the people who manage custody would take a transaction, go out to these computers, get it signed, put it on the net, and we'd put more money back into the hot wallet. And that happens frequently, if we see a lot of withdrawals in a currency. We could frequently run out of funds, and we do that. So it's not like it's unheard of in the normal case, but that keeps us relatively safe. Mt. Gox, it was a famous site. They kept all their currency online. So when it got robbed, they lost everything. There's really no chance that's going to happen here. Right. We also worry a lot about supply chain security, right? There are some things we pull that are open source that, we pull using tools that I'm sure, your developers that you use yourselves, things of that sort. But when it comes to the wallets, we are pretty picky, right? We want that wallet, we pretty much want that wallet to be coming from an official build or an officially labeled release that's on GitHub, right? And we want it to be coming from the right GitHub account. You can't fork it and tell us to take your chain from it. We want to be talking to the devs. We want to be sure we're talking to the devs, right? Because people pretend they're the devs, tell us to download something from someplace else, right? And then who knows what happens. This is, right, this level of communication is exhausting to some extent, right? It's labor intensive. But we don't do it for all our components, but for these wallets, we need to worry about them. So next I'm going to talk about attacks on user accounts. So this is not specific to crypto exchanges, cryptocurrency exchanges, right? People want to hack into your bank account. My mom is always getting phone calls asking her for a bank account username and password. In case you're worried, she's safe because she doesn't know her username and password. But this happens all the time, but it happens much more here, right? It happens a lot. Also, part of the trouble with getting someone's username and password, right? Part of hacking into someone's bank account online is, what are you going to do with the money? You're going to have to transfer it somewhere, right? You're going to write a check and mail it to yourself. That's not very good. You're going to transfer it to your bank account. Again, we're looking at 3 to 5 days for that to settle. And when my bank figures out there's a problem, they're going to call up the other bank. You're never going to see your money. So if you can hack into someone's account and do a withdrawal, which happens over the net, the money is gone. So we see this. When we look, we work with other exchanges, and we look at what we see. We could track where the funds are going based on the Bitcoin address they're extracting to. We see individual people pulling in $1 million a month, which makes me wonder why I'm doing what I'm doing, because I'll tell you, I only make half that. Right. So the way they do this is phishing attacks, right? People make bad phishing sites. They also make good phishing sites. We have seen a company that was selling Poloniex.com in a box, $400. You buy it, they gave you, I don't know what they sent you. They gave you a download of some kind, and you could put it up on your site, and it was going to look just like our site. And they do this for other crypto sites as well. Right? There's also, I don't know if you're worried about account takeover and phishing, but recently, in the past year or so, there's been a couple of tools that have come out that produce dynamic phishing sites. There's one called, instead of being Nginx, it's called EvilGinX. You put it up, you configure it by pointing it at another site, like you point it at a cryptocurrency exchange, and it does dynamic proxying of everything live. You're up and running. Which is very interesting, because if you have a live site that's up and running and you ask someone to authenticate, and then you can also get their two-factor authentication at the time, because even though that's typically short-lived in time, if you're logging in dynamically, you're doing it immediately. We see computer mobile device malware. My exchange has been plagued by some Android stuff, right? The guy stole some credentials years ago and keeps sending us emails telling us he's going to publish them. Right, if we don't send him $1 million, which, being he's been doing this for a couple of years, one has to wonder what he really has, because we've sent him nothing. But we certainly see. So actually, I can't say we've been plagued by it. We're plagued by someone who claims they've done it. I don't have any evidence that it actually occurred. Fake support sites are one of my favorite. Particularly in the heat up to the end of 2017, 2018, when crypto was growing tremendously. All the sites had support problems. Poloniex, which we didn't own, Circle bought it in February, but Poloniex, when we bought it, we got like 140,000 support tickets, just to sort of give you a perspective of of the amount of backlog. It was nothing to have your ticket sitting for a year without someone having taken a look at it. So support sites started popping up, right? They'll help you get faster, right? They're a subcontractor for Poloniex. They'll help you get it. All you need to do is give them your username and password, right? Now, who would do that, you'd say, right? I mean, that seems kind of stupid. So to make the thing better, right, you have to pay them $39.99. So, because, well, now it sounds real. I'm going to give them my username and password. So you pay these people $40 and then they steal your account. So, yeah. We see the email account takeovers. We worry a lot about it. I have become, since over in this job, I have started moving all my important financial things over to an @Gmail account, @gmail.com, because it's really hard to steal a Google Gmail account, right? Especially if you crank up the security, use YubiKeys on it and such. Because people lose their, right? We get contacted by support. People tell us, I've lost my password. I can't log into your account anymore. But I have my email. Can you email me a password replacement? And we're like, okay, let's talk about it, right? And things aren't bad. And then they start posting on Twitter that they lost their job, their cat's dead, and their mom has cancer and needs chemotherapy, and we're keeping their money. But we look and we know they're a thief. I mean, we know it. But they post, they keep hoping, they only need us, it only takes a minute to post a tweet, and we only need to give them one account to make it all worth their while. So we see that often. SIM swapping, right? This is when they steal your mobile phone number, right? I don't know if you're familiar with it. They call up Verizon, they call up AT&T, and they convince them to turn that you lost your phone. They say you lost your phone, here's my new phone, and suddenly your phone goes dead and someone else has your phone number. And then if there's any phone calling associated with the account or any texting, it goes to the attacker's phone, not to your phone. While we don't rely on SMS, we've had several employees who've had this happen to them. It's really a mess. Again, I don't work for them, but Google Voice numbers for your most secure things, because Google does not do this, right? If you can't log into your Google account, you lose access to it. So Google will not, right? The phone company, if you beg, will try to help you out. Google says sorry. Right, if you use a private domain, which is what I do, I have some little custom domain, 7 letters, including the dot. So I make everything that I think it makes it real easy to filter out spam. But so here what they do is they call you a domain registrar and steal your whole domain. And then it's gone. Lastly, they try to engineer a support staff, right? With my mom has cancer and she's going to die if you don't give me my money. And the worst part is, maybe someone really is in trouble, right? It's hard for us to know, but we can't give you your money if you can't prove it. Okay, so, right, to make it easier, we have people like this. This was one Twitter user who had, I think it was 65, 85, I don't know, let's say 65,000 followers. Someone asked him, what crypto exchange do you use? And here he is, he went and I've blacked all the information out, but he went and he said which ones. I found this by saying I use and the name of a cryptocurrency exchange and search for it on Twitter. Even freakier, if you say my crypto balances are, you will see screenshots of people posting where their money is and how much they have. That was very common into 2017, 2018, when people were just, overwhelmed by the amount of money they were making. So this is like too much help to an attacker, right? Don't do this. And there's not much we could do about it. This person who has 65,000 and all they do is tweet about cryptocurrencies. So people follow them. This is their thing, and they're posting this. So what do we do to help the users? Oh, I should mention, if you lose money in your bank, if your account gets broken into, they hassle you and they give you back your money. If you lose money in a cryptocurrency exchange, they apologize really well. Okay, all right. We cannot afford to be giving back this money. Neither can our competitors. at least if you've just given away your stuff, right? There are situations, where maybe it was our fault. We make you whole in those situations. But if you just gave away your username and password, it's over. I'm sorry, and I feel, I say I'm sorry, but I feel terrible, right? Because these are people who, some of which, we see them coming from poor countries. It makes me wonder if this was their life savings, and somebody stole it. It's terrible. So, strong authentication, big win. You push for 2FA. We do this, we and other exchanges do this in various ways. Some exchanges don't let you sign in. They make you, the moment you sign up, you have to sign up for 2FA, Google Authenticator. No exchange that I'm aware of uses SMS, right? Because it just happens too often, the SIM swapping. Other exchanges will give you perks. They'll give you more functionality, right? Maybe you can only deposit $100, and once you get over $100, then you need to kick over into 2FA. That helps with the, we have this thing where we have users who are, just sticking their toe in the cryptocurrency water, if you will, and we don't want to scare those users away. They should come and learn. We're big crypto fans, and we want people to learn, and maybe some of them will be big customers. But we also need to provide the security for the people who have accounts worth tens of millions of dollars. So the security has to sort of adapt. So when you're providing the two-factor authentication, SMS maybe is better than nothing. I don't know, if you have a lot of money in your crypto account, SMS isn't really better than nothing. All right, they just arrested some guy working for Verizon who was working with crypto hijackers, switching people's phone numbers. Right, I don't know where the guy was. The guy they arrested was in Florida. I forget where the Verizon employee was. That was like 2-3 months ago. Google Authenticator is pretty good. Right. The trouble is, we see customers who get convinced to give out the seed number of their Google Authenticator. So even though they don't lose their phone, they give out the seed number and it's gone. Google Authenticator also is subject to phishing, right? If somebody puts up a phishing site, they get your Google Authenticator number and they log in to another site immediately, it's going to work. And we try to do things like all significant operations require 2 Google Authenticator codes that have to be separated by 1 or more iterations, so that if somebody managed to steal one of your codes, they're going to have to steal a second to get to do anything important. Right? I'm a big fan of YubiKey. I don't know if you're familiar with it, right? YubiKey works with the browser to provide your 2FA code, and it will never provide it to the wrong site. Right? The browser says, give it to me for the current site, whatever it is, and YubiKey will produce that code. So if you don't have, if you think you're on Google.com but you're on Goggle.com, YubiKey is going to give you a different code. So big fan of that. Okay, so other things we do. Have I been pwned integration? We have a lot of data about passwords that people try, right? Because we see 60, 70,000 an hour. So everything we see is on have I been pwned. So exchanges start, if you try to sign up with an email or a password that has been pwned, they don't let you, or at least they greatly discourage you from doing it. We have a maximum daily withdrawal limit. By default, it's 25,000 once you've completed your registration. If you want to withdraw 26,000, you got to withdraw 25,000 today and come back in 24 hours and remove the next 1,000. Some users ask us to up that, and we will. But what that means, some users also ask us to lower it because they understand that if you have, it's really hard to steal more than, right? If someone only has like 1 shot, they can only steal your daily withdrawal limit. They can't steal more of it. We have an anti-phishing service. They take down sites. They, scrub the internet. They look at app stores looking for fake apps, and not just the formal ones. They look at China, largely because Google's app store won't run. China has a whole bunch of secondary app stores, and they go through there and then they, execute trademark infringement and such and pull these things off. Um, uh, I don't know, so I'm going to pass. No, I do know. I'm not sure I could say. We use multiple vendors, though. So, right, lastly, we try to do things that are sort of risk-based, a little AI-ish, and then if you do a withdrawal and something looks fishy, maybe we're going to ask you to confirm it via email. Maybe we're going to actually have a person take a look at it, which is very strange, right? You couldn't imagine going to your bank, making a withdrawal, and then saying someone's going to have to look at it, and support doesn't come back on until 8 a.m. tomorrow morning. But in the crypto world, that's kind of normal. Right, so here are just some of the things we see. Right, if you're trying to do a withdrawal and it's from a new IP address we've never seen, that's quite possibly bad. If you've just changed your password, just changed your authentication in any way, these are things we see associated with, these are things that, right, our data sciences team has pulled up as sort of the most risky behaviors, right? Because we have a data sciences team who grinds all our numbers and tries to produce some AI-based risk analysis engine.
What is the trading history one mean?
So sometimes people deposit money and then just withdraw that money. The reason you do that is because you deposit some Bitcoins, but when you withdraw, you get different ones. So you do that if you're trying to do money laundering. Sometimes there are various patterns that we've identified as being risky. Okay, so I have like 8 minutes left. This is the fun stuff. So this is not something you have to worry about if you're a bank. The government worries about the US dollar, about the EU. I mean, I guess you need to worry, banks do some currency hedging, where they'll invest some of their money in a foreign government's funds or something, but money's money, right? It stays around. That is not the case on the blockchain. Because of the way the blockchain's set up, there are a few problems. First of all, it's not instantaneous, right? Which, in terms of a transaction, happening in 15 seconds for a person, you could sign on today and transfer, $1 million to someone in some random place in the world. They don't even have to be online, and you could do that in 15 seconds, and at a charge of like a few pennies. That's kind of cool. But if we're talking about writing an application, the fact that you might have to wait 15 seconds to find out if your withdrawal actually worked, I mean, what the heck? Some blockchains, or when the blockchains are busy, you cannot get it right away. You could have to wait hours sometimes watching, hoping it happens. There's, of course, no transaction between a blockchain and your SQL database that you have inside keeping track of things. So we have to have a lot of code that looks at the blockchain and tries to make sure that it's up to date with our database. And we worry, we have to worry that we don't ever credit someone funds that they don't actually have yet, something like that. The big problem is what's called a reorganization. And I'm going to step through that and talk about it, our protection. So here we have the main chain. I don't know what currency. Let's call it FooCoin. Blocks are going along. Here's some victim exchange at the top. At some point in time, the person removes some funds from block. The attacker removes funds from block 3 and puts it into their exchange account. A little bit later, the exchange says, "Okay, we see you put money in here. We're going to credit your account." At which point in time, the attacker sells their currency. Maybe always, right? I think every time I've seen what they do is they sell it for Bitcoin and withdraw the Bitcoin because Bitcoin is the most liquid. So if they're trying to get away with stolen funds, better to get away with something like Bitcoin than these smaller ones. Okay. Meanwhile, in secret, the attacker is building their own blockchain, and they start mining blocks. When they're mining these blocks, the first thing they do is transfer the money out of that same account X, right? The money that they gave to my exchange, they transfer it to some other exchange. Now, nobody knows about this because this is all happening in private, right? So, the attacker knows, but everyone is just paying attention to the green blocks. And the way it works is, because it's such a distributed network, it has to take into account the fact that network will get separated. And so sometimes you'll get reconnected and you'll see stuff that you missed. So when that happens, when I get two blockchains, right, from the network being reconnected, the rule is you pick the longer one. So if the attacker has more hash power on this, right, has more hash power, they're going to be able to produce blocks faster than the regular blockchain. So if we talk about this being, between the two blockchains, we have 100% of the hash power. The attacker needs to have at least 51% of the hash power if he's going to guarantee that he can outlive. That's how come it's called a 51% attack, because they have at least 51% of the total available hash power. So when the attacker gets this out, so keep in mind, the attacker has already deposited funds, gotten them, converted them to Bitcoin from this poor victim exchange, and gotten them out. So suddenly the attacker says, I'm publishing my chain. They publish their chain, sends it to the nodes, and the nodes are like, oh, how did we not see this? This chain's 7 blocks, ours is only 6. Everything switches to block 7. The new main chain is now highlighted in green. The blue blocks, they're what's called orphans. They are garbage, right? They're just, maybe at some point in time we thought that was what the world was like, but it wasn't. And we can just forget about them. Suddenly whatever exchange this is, suddenly this exchange now sees this come in, right? Because this wasn't broadcast previously, now it's broadcast. So now the attacker gets their money deposited. So the attacker has whatever money they had in account X, they have it deposited in this exchange, and they also sold it for Bitcoin and got it up there. This is called a double spend attack, because they spent the same money twice. This process of when the blockchain switches to the bigger one is called a reorganization. This is really terrible, right? You can't imagine doing business with a bank where it could do something and it could then be told that something that happened hours or in cases days later actually didn't take place. And whatever transactions they made on that, that's their problem. So what happens in this situation is the victim exchange has to foot the bill, right? They have to buy the money, buy that coin back, because some poor customer bought it and we don't own it. Very expensive. To take it out of theory, in May, there was an attack. $18 million got stolen from 6 exchanges. In January, Ethereum Classic, which was the 18th largest cryptocurrency, got held up for $1.1 million. You can rent the hash power, right, which lots of people do. So for Bitcoin Gold, the estimate was it cost $4,000 an hour to rent, right? They made 18 million. Or maybe they had to run it for 12 hours. You could do the math. Okay, I'm going to skip a few slides because I am short on time here. So to execute one of these attacks, you need to have the coins to double spend, right? You can't make coins, you just spend them twice. You need to have the hash power, which you can rent. It could be expensive, and if your attack fails, you still rented them. You need to have some technical skills, and you need to have this, a strategy for quickly and anonymously liquidating the coin. That's where we could help. So what we do to protect ourselves is, first of all, we only let people we know do business with us. Most attackers don't want to do that. If they're going to do this ripoff, they go to exchanges that let you act anonymously. Because who wants to give their ID and then use it as a thing? Now, of course, you could buy stolen IDs and fake register, but why bother with us when you could do someone else? We have the withdrawal limits. You execute the attack, but you can only take it out $25,000 a day. That's not so good, right? Because after a day, after minutes or hours, we're going to figure it up and we're going to lock your account. Then you don't get your funds. And the next thing is, we could track the currency's health and try to set the number of confirmations appropriately. Right? So when this happened, you'll notice the account was deposited in block 3, right? And then it got confirmed in block 4, and then again confirmed in block 5. So the cryptocurrency exchanges say, right, in this case it would say, I don't give you your funds until I've seen 2 confirmations. So what that means is if you're going to execute that 51% attack, it has to be at least 3 blocks long, right? And the longer that is, the more expensive it is, the more chance that's not going to happen. So 3 blocks is not interesting, right, for a weak cryptocurrency, but so here's a tool we use. Right, we've been writing this over the past 6 months. I'll step you guys through it real fast, though. So at the top, we have input. This is looking at Ethereum Classic, which was, right, and that's the date range on the right. The 51% attack is in here. I'll get to it in a minute. What's in the bottom right is the total hash power of the currency. You know, the more hash power it is, the more expensive it is to, if you're going to have to get 51%, the more expensive it is. You'll notice this is going down. So, I mean, as cryptocurrency has been worth less money, people are getting out of the market, so this is not uncommon. If you were to go rent it, there are sites where you could rent it. This is how much it's going to cost for you to rent it. This is how much is available for rental. How much, right, how much of this number is available. As you'd expect, if this number is going down, this number goes up. It becomes real anxiety producing when it's at 100%, because it means someone doesn't need to buy computers to execute attack. They can just go ahead and rent the whole thing, which costs thousands of dollars. But it, you know, to buy these machines, the machines are tens or hundreds of thousands, and you need to buy lots and lots of them. The last graph here, this is our confirmation time, right? From beginning of time through December. If you deposited Ethereum Classic, you had to wait 7.5 minutes before we'd give you your funds, right? So I'll cover that in a second. This is very strange to me. I don't know why we have such a strong dip, right? We have a 50% drop in the cost. I'm not sure where that came from. I've looked at it. I can't figure it out. Here, this tool, right, it produces alerts for us, right? It tells us when numbers are going bad in the wrong direction and such. So twice, once in December, once in January, we looked at how much time we made you wait, and we went from 7.5 minutes to 30 minutes, then to an hour. The 51% attack happened the day after I did this. We would have been susceptible to the 51% attack. On this side, we were not susceptible to it on this side because the attack wasn't long enough. I felt like I was brilliant. It was wonderful. On the flip side, you know, I only made it by 1 day. You know, if 1 day in the other direction, you know, and we're part of that $1.1 million attack, possibly. These 2 little red dots up here, these are showing the actual 51% attack when it occurred. So this attacker did not rent, right? If the attacker had rented 100% of the blockchain, we would have seen this drop down to 0. So it looks to me, we have a little spike here, and we have a little spike in the price of rentability. It looks to me like the attacker had close to half the blockchain, but in hash power, but not quite. So it's probably a miner who was doing this, who had a lot of hardware. And then when it came right down to time to do the attack, they just rented a little bit. Right? I don't know who it was. And being it wasn't my exchange, I'm not very concerned about it. Right? One exchange has come forward, right, and they were a few $100,000, and they are repaying, right, they're paying their customers, right? The customers won't end up losing any money. Okay, so this is, like I said, this is a tool that we've been working on. First time it's been shared publicly, by the way. So last slide. So best practices. Best practices at the application layer, you know, OWASP top 10. These are table stakes. If you don't have them, don't even think about it. If all your engineers don't understand this, don't let them do code. Right? This is, you just can't even think about it here. It is too freaky. The wallets, these are vendor management on steroids. It's freaky. The security, I know how to make something really secure, you know, and I'm sure I could do something our, you know, multi-million-dollar financial institutions would be happy with. But I need something that also was going to let us have a quick adoption rate of new users. That makes it much more challenging, and we need to adapt both in options as well as using settings and triggers in the app. And lastly, these 51% attacks, it's an arms race. We have this tool. I've seen a blog post from Coinbase. They posted some stuff. They have a different tool. It had information I didn't have. So I don't know exactly what their tool is, but we're all working on these, trying to figure out what's the best one. So, questions? I think there's a mic, which I was supposed to be repeating questions without it, but so I apologize to the people on video.
So the biggest pools out there can produce 6 blocks in a row, right, at most. And the question is, why don't you wait for a certain number of blocks to confirm the transfer as a security mechanism so that there's no chance of having a 51% attack?
So, right. So how come we can't just stop it? And so the 51% attacks, and there's sort of two answers. First of all, we can never wait long enough. There could always be a 51% attack eventually. We don't know what hardware is there. And in fact, there could be hardware invented in a year that would be, let's say, 1 million times faster than the current hardware that could come back and redo the whole chain and execute the attack, right? Because, when I showed this, I showed the attack starting in parallel, which is the cheapest way to do it. But if you had explosively fast hardware, you wouldn't need that. The other problem is, right, you said 6 blocks, right? You're probably talking for Bitcoin specifically. For Bitcoin, I think we only wait 1 block. We require 1 confirmation. But the problem is that many of these other coins are less secure. The problem with Ethereum Classic, right, which has never been a favorite currency of mine, is it uses, people run these ASICs, these customized hardware boxes to do the hashing on them. And Ethereum Classic uses the same hashing algorithm that Ethereum uses. And there are many Ethereum mining pools that have more hash power than the whole Ethereum Classic. So any one of those mining pools could execute a Ethereum Classic attack forever. So there's no way to protect against that. We could make you wait days and days, and then it turns out our customers go to our competition, right? So, getting attacked is a business risk, right? But losing all our business is a business risk as well. And we have to weigh those against each other.
Hi, I guess like the question that I'm about to ask, it's early to ask this question, but I'm just gonna do it. What are you doing to protect? I mean, I know it's, again, I'm saying it's early for quantum computing, but have you thought about that?
Yes. All right, we have a cryptographer on staff, and she worries about lots of things. Quantum computing is one of them. She's a great big nerd. I really like her, by the way. So wherever we can, we avoid using things that are going to be susceptible to quantum computing. Some of the coins allow you to use 2 different signing algorithms, one that's quantum resistant. So, if we have that option, we use that. The other big thing we do is when we're taking on a new asset, right, part of it is there's a security and a cryptography review. So we look at, a new coin and say, is it using a good hash algorithm? Is this hash algorithm going to be quantum resistant? If it's not quantum resistant, do they have a plan at least for it becoming quantum resistant? So, we do our best and we keep an eye on it. And, if suddenly there were to be like a feasible attack on a quantum attack on our currencies, I imagine we would take them offline very quickly and then try to figure out how to get those people their money. I think there was a hand in the back left. Any more questions?
Hi, so I'm not sure if you've already kind of answered this, but what kind of security precautions do you take since you do have some hot wallets when, different cryptocurrencies update their wallets, right, and update new functionality and that kind of stuff, right? Because I know sometimes Poloniex does
Yes.
have to update your wallets. And
We have a team that basically updates wallets all the time. Right? That's their job, right? Because with 60-something currencies, it happens often. And some currencies produce really good code that runs well and updates well, and then there are the others. What we generally, when we have to do an upgrade, we take it offline. Right, we back up all the keys and everything. And then we do the update, do internal testing, and bring it back online. Because we've backed up the keys, if something goes wrong, at least cryptographically, we know how to fix the problem, right? And by working with the coin team, we'll be able to recover our coins, right? Because, if you have the private key, you have those coins, right? Even if you don't have working software, you'll be able to, get those coins. It's challenging.
So if more identification is verified at like the customer onboarding activity, is there any consideration around how many confirmations are needed for a transaction? Like a KYC type of.
So currently, the question is, right, so the minimum number of confirmations, right. So how dynamic is this? Is what I think the question is, right? How long do we wait? So I do not think any exchange, I'm not aware of any exchange, let me say, that has something dynamic on that based on something involved in the transaction. That said, I know we've been talking about that. I've seen things on Twitter about it, suggestions about it. So first of all, one of the first things that I've been talking about is if it's only a little bit of money, let's just give it to them. Let's give them a good user experience, right? And if people deposit $3, let's just give it to them. And if they stole it from us, okay, they stole it from us. It's not just one person. We have to look across all the deposits in that currency, right? Because a single attacker could be depositing to hundreds of accounts, though hard because they have to ID to hundreds of accounts, but it happens. Right, there's also other things we've been talking about is looking at the health of the network at that very instant. These graphs here are really pretty constant. For some of the smaller coins, the graphs shoot up and down, having 50, 70% swings. What happens is the miners, there's multiple currencies that use the same machines, that use the same hash algorithm. And so the miners run software, which is the most profitable place for me to mine. So they mine on this coin. And then suddenly they're like, oh, wait a second, that coin is going to be better. So the miner leaves. And eventually, all the miners leave because that coin's better. Which, of course, now that everyone's mining over there, there's more competition and they make less money. And so they swap again. So we see very erratic behavior. So we don't do anything like that, though there's discussions about this sort of stuff. The most interesting discussion I guess I've had on this is that when we see drops in the rentability here that might indicate a 51% attack, that perhaps the exchange should go rent hardware and support the coin, right? We go out, rent it, and we could boost that back up by running our own nodes. I think it's awfully complicated, right? We start to run into some legal problems, right? We're already over time. But we start to run into legal problems because we could be damaging other people's transactions when we do that. But so we talk about these, and I would imagine in the next 6 to 12 months, these things are going to all become a reality at my exchange and at our competitors. Because the attackers, there's so much money involved, they have roomfuls of smart people working on this. Well, virtual roomfuls. I don't think these people actually meet each other. Any more questions? So listen, we're already, I think, 15 minutes over. Is that? Right, so I'll be around. Thank you all for coming, especially late on a Friday.